A very good evening. Respected Principal and today's invited speaker, Dr. Anish Gangan, Administrative Officer Mr. Shantish Ravrani, faculty members and dear students. I am Sandhya Vaingankar, Librarian of Sspmcoe College of Engineering and Secretary of NDLI Club, welcoming all of you. Today, the Central Library Department of our college, in association with the National Retail Library of India and the Indian Institute of Technology Kharagpur, is going to present a webinar on energy crisis, role of energy management and renewables. The objective of this webinar is Introduction to Energy and Energy Management, Importance of Energy Efficiency for Sustainable Development, and Role of Energy Management and Renewables. Let me introduce today's speaker. Dr. Anish Gangan is a mechanical engineering graduate from University of Pune and has done Masters and PhD in Energy Science and Engineering in 1997 and 2013 respectively from the Indian Institute of Technology, Bombay. Presently, he is working with SSPN College of Engineering, Kanpur as a principal. He has a patent to his credit and authored several papers in international journals and conferences. Dr. Anish Gangan has delivered several lectures on a variety of topics. He has worked in industry as an energy management consultant, worked on government-funded research projects, and have been teaching for over 15 years and has a total experience of more than 20 years. Now, I would like to request our guest speaker to share his valuable thoughts with our participants. Sir, please take a charge of session. Thank you.
Good afternoon, everybody. I hope I am audible.
Yes, sir. Yes.
Thank you. I will just share my screen. Just tell me if you can see the slides.
Yes, sir. It's visible. Only make a slide. Okay, it's visible. Yes, it's visible.
Yeah, thank you. So starting with today's webinar. Today's webinar is on energy crisis, role of energy management. So outline of today's webinar, energy and environment, current scenario, what is energy management, and how we can tackle this problem with the help of renewables. So we'll start with what is E for energy and E for environment. E for energy. So you know that we consume lot of energy for our day-to-day needs. This energy comes from electricity, it comes from food, water, food, shelter, correct? So all this energy is treated as a commodity. So if you look at water as a commodity, when do you pay water bill at your home? You pay your water bill after using that commodity. Normally, does it happen when you go to your any hotel or anywhere else? You have to pay first and then you get your uh, food or water, correct? But energy is one of the commodity like water which you pay afterwards. So it is free to use at the start, but it is billed at the end. So this is the case of energy. So this becomes a very critical factor. Energy is a very critical factor for economic development. So how do we categorize this energy? So we say that a developed country like America or UK, these are rich countries because what are the specification or benchmarks by which you decide any country is rich? The country is rich depending upon its economic development, and economic development depends upon use of energy. So per capita use of energy is a factor which decides how much a country is rich. So if you go to African countries, per capita energy will be very less as compared to per capita energy of a developed country like America or England. So how do we get this energy from? So there are primary sources of energy and secondary sources of energy. So primarily we use what? Coal and oil to satisfy our energy needs. Okay. So where does this oil come from? Oil comes from all the petroleum products, crude oil. This is not a home cooking oil, it is crude oil. So coal and crude oil is used to satisfy our energy. And crude oil is refined in these refineries of BSN, sorry, refined in Reliance or your HPCL, BPCL refineries and separated into petrol, diesel, and gas. So this petrol, diesel, and gas are used for transportation sectors. If you look at India's energy need, 30% of our energy need is made by crude oil, and 70% of that is oil is imported. So we import oil from many countries like UAE, we import oil from Iran, we import oil from Russia. Similarly, we have coal as our factor. So coal is also imported from Australia and Indonesia. So India has got very scarcity of these resources. Like we have very scarce oil and as well as coal. So if you look at vehicles, more than 700 million motor vehicles, they need refill. And this refill means what? They need to fill petrol every day. So this number is set to be grown to about 1.3 millions by 2020, and further it will grow to 1.5 millions is the current rate. It will go ahead, and once we'll feel that one day will come. Today petrol is almost 115, 111 rupees. So one day we'll get a feel that this petrol will be 200 rupees per liter. Correct. So this will grow on. Why? Because there is scarcity of oil. Next, E stands for environment. So when we take care of energy, at the same time we need to take care of balance of environment. So mostly coal and these petroleum fuels, which are primary sources of emission, they emit carbon dioxide, carbon monoxide, nitrogen oxide, and sulfur oxide. These four are very dangerous gases, and these contribute to our greenhouse uh, effect, and that's why we have lot of environment issues. So at the same time, we need to keep a balance in energy as well as environment. Environmental pollution is damaging the life of our planet on land as well as in the sea. So these emissions are causing global climate change. So it is said that every 10 years we'll observe a temperature rise of 1 to 2 degrees centigrade because of this carbon dioxide, carbon monoxide, nitrogen oxide, and sulfur. So this leads to a disaster at the end, and this causes harm to our environment. So what is the solution for this? So today's we should switch to either natural gas, fossil fuel, or we should find a alternative like renewable energy. So we'll see how energy is classified. Energy classification is based on either it is primary source of energy or it is secondary source. Then we have commercial and non-commercial type of energy, and renewable and non-renewable energy. We go one by one. So primary and secondary energy. So in primary energy, it is found in nature. Very easily you can find this energy in nature. So what are these? Coal, crude oil, natural gas, biomass. These are all primary energy sources. Similarly, nuclear, hydro, wind, and solar. These are also primary sources of energy because nuclear energy comes from uranium and plutonium, thorium. Correct. These are available in our mines. There are mines of uranium and thorium, plutonium, where we get this. Hydro comes from rivers or lakes or big water resources. Then wind and solar. You can find it anywhere where you have a location where you have wind velocity, or and solar in India. It is said that we have 360 sunny days in India. So India is very rich in solar, hydro, and wind type of resources. Then we have secondary energy resources. So this was primary. So now electricity. we don't get electricity anywhere. We have to convert electricity. Correct. So this is called as secondary energy source, heat. So either we have to burn oil or coal, or you have to burn natural gas or biomass, so that we can get heat as energy. Steam is again you have to burn water or some gases, so that we can get steam as our energy. So this is secondary source of energy. Let us go to second classification. Second classification is commercial and non-commercial energy. So by word you can see that commercial means what? The things what you can buy, and non-commercial means the things which you cannot buy. Means you cannot buy, but you get it by other way. Oil, gas, and coal are commercial type of energy. So oil you have to buy, gas you have to buy, coal you have to buy, electricity again you need to buy this. So now non-commercial we have firewood. So you can take wood and just burn it. Nobody will ask you what is the cost of firewood. Then agricultural waste, solar water heating. So you have to buy the facility, but after having solar panels, once you have it, the cost of electricity is free. Next classification is renewable and non-renewable energy. Renewable energy, the energy which cannot be, you cannot say, which never ends. Correct. So wind energy will not end at any time. Wind will keep on blowing here and there. Solar energy, till we have sun, till our planet exists, we have solar energy. It will never replenish. Biomass, then hydro, geothermal, all these are what? Renewable energies. So now our focus in future is on this renewable energy. Recently, our Prime Minister has also dedicated a renewable ministry, renewable energy ministry. Also, we have this from this year we have made some policies in Indian government for renewable energy, so as to invest in renewable energy. So around 20,000 crores is the investment this year, which would be made in renewable energies. Let us see non-renewable, again oil, coal, natural gas, nuclear. All these are what? Non-renewable energies. So we'll see some comparison now. So this is per capita, what I was talking about in earlier stages. Is per capita energy consumption. You can see that this is a old graph, I will say. Now the things have changed a little bit. You can see India is at very peaking level, very small level. It is just picking up. So it is having low per capita energy consumption. Even China is not that good. But look at these giants like USA. Look at it. So see their per capita energy consumption. Look at Canada. So now you can see that USA and Canada are having higher electricity consumption. One reason behind Canada having more is that there is cold in Canada. 9 months are the temperature is below 10 degree, and 3 months you have temperature between 10 to 20 degrees. So that is why they use AC. Whenever you use heaters or AC means heaters basically, heaters. So every time you go into their houses, you'll have heating. Correct. So that heating requires electricity, and that is why you can see that the Canada people they use lot of electricity. So comparison, if you look at other nations like Japan, France, United Kingdom, and South Korea, they are also way ahead of us. Now this graph is old. Now China is on second number, but because of I didn't get a clear graph of recent energy consumption, you can see that China and India are at least level. This graph is from 1999 and source is from IREDA. Okay, so you can see that energy consumption now is directly proportional to economic growth. So now we'll go a little bit deep into it. Let us see the primary energy demand of whole world. So you can look at coal, oil, gas, nuclear. So see that in the era in 1980 to 2004, you can see that hydro, correct, then biomass and other renewables were very less compared to nowadays. You can see 2004 to 2013. You can see there is a rise in some of the graph. That last graph of other renewable is rising, correct? So there are changes in first three sources: coal, oil, and gas. And let me tell you, if you plot a graph from 2030 to 2050, you'll exactly see a reversal in this graph. That means your coal, oil, and gas will be least, and your hydro, biomass, other renewable, and nuclear will be at higher level. Okay. So this graph is of metric ton of oil. TOE means what? Ton of oil equivalent. So metric ton of oil equivalent. So it is huge number, and the contribution of renewables you can see is increasing significantly. So this is another study in 2006. It was made from Terry. So you can see that again on y-axis we have metric ton of oil equivalent, and on x-axis we have all the resources and their year-wise graph. So in 2001 you can see that major contribution was coal, and if you look at 2031, which is a which is a projection of current scenario, you can see that oil coal is still at a high level. So, and you can see a very small area of natural gas, hydro, and solar, which is just picking up. So, after 2030, you will be able to see a very drastic change in this graph. So, this blue area and yellow area are going to become less, and we'll be having yellow. I think this is light yellow, and blue area will be less, and yellow, which is for nuclear, orange, which is for renewable, solar and wind, and hydro and natural gas will increase. So total primary commercial energy has increased 7.5 times from 2001 to 2031. So from 285 metric ton of oil equivalent, we have increased it to 2123 metric ton of oil equivalent. So traditional fuel, which is from primary energy consumption, has decreased from 3.5% to 4.4%, and coal and oil remain dominant for fuel till 2031. Now, recently you might have seen a war which is happening. The war is in between Russia and Ukraine, which emerged from some message. Okay, sorry. Ah, so war has emerged out because the basic reason behind this war is a natural gas pipeline which goes from Russia to Europe through Ukraine, and Ukraine takes some money for having that maintenance of that natural gas pipeline, and they started increasing the money for Russia, and finally what happened? A war took place, and the main reason for war was energy. So now it has become a serious issue, and you can see the share of coal here is 55% in 2031, and share of oil is 36%. So till 2031 there is no issue. But what will happen after 2031? We have oil and coal reserves. Coal reserves will last only for next 100 years, and oil reserves are going to replenish in 2045. There will be no oil after 2045. So what will happen after that? We have to be prepared, and we have to shift our oil and coal, which are used for as a dominant fuels, to nuclear and solar. Okay. So again, the same comparison, I will not go in detail. You can see that coal is 49%, 52%, and 44%. So almost 50% of energy comes from coal, and from oil you can see 33%, 33%, and 27.9. That is 28%. So almost 28 to 30% of energy we get from oil. So around 80% of energy we are getting from coal and oil from 2001 to 2031. So electrical sector in India. So installed capacity is 210 gigawatt, which is taken from 2012. Now it has reached to around 350 gigawatts, and it is world's. This was in 2012. It was world's fifth largest. Now we have become world's fourth largest. Then per capita average and annual domestic electricity consumption in 2009 was 96 kilowatt hour. So where this unit comes from? Kilowatt hour. Kilowatt hour is nothing but one unit in our meter. So it is said that 96 is the average electricity use in per month in rural areas, whereas in urban areas you can see that it is 288. If I draw a pie chart of this, you can see that 21% of our energy is consumed by agriculture. Then 35% of the energy is consumed by industry. And you can see that 7% is consumed by others. Others means it is for various other reasons. 9% is for commercial use, and for domestic use, which is total remaining of this, it is almost equal to I think 60.7. So remaining part is around 32% is for domestic purpose. So agriculture share is increasing because of new equipments which run on electricity, and they are used in agriculture. So you can see that this is electricity capacity and availability in India. So these figures are old, but let us take this as case study. Anybody wants to ask any question? I'm getting some audio from other sources.
So students are joining. That's why it's.
Okay. So I will continue. Let other students join. So you can see that total installed capacity in gigawatts is 2009. Base load is 893371. Available peak load supply is 125. Demand base load is 985317. Demand peak load is in gigawatt is 140. This is from standard resources. You can also check latest loads and peak loads from Indian Energy website. So you can see that there is a gap between the installed capacity and the peak load. So that is why if we are not able to meet the demand, correct, demand supply gap remains, what we have to do? We have to do a load curtailment or load shedding. So base load and peak load we have to take care of, and if we don't take care of this, we need to go for compulsory load shedding. So this is total installed capacity. This is source-wise. Coal has got 57. That is thermal power station. Hydroelectricity is dams, which give 18.77. Renewable, it's increasing now. Now many states have, like Gujarat and Maharashtra, have taken lead and they have installed capacity. Now this 11.94 has become almost 40,000 megawatt. We have installed capacity, and we are having some 2 gigawatt plant which is coming up in Gujarat. Then we have gas, then we have nuclear, and we have finally crude oil. So crude oil is less, but if you look at transportation, this oil will be more. If you look at state, central, and private sector, state have got 41.5, central uh, central as a sector has got 30%, and private players are around 30%. So you can see that total how we can have a total of 209,276 megawatt of energy. Now this is bifurcation. So contribution of renewables, as I said, is now they are increasing this, and once we increase, we would be able to shift that coal and gas load on renewable energy sources. So you can see that in 2010-11, base load requirement was something 861, 591 metric unit against availability of 788,355. So 8.5 to 10% of deficit means what? Deficit is difference between your requirement and availability. Correct. The requirement is high and availability is low, so we are running at a deficit of 8.5%. So what happens during peak load? Peak load means at the time where everybody is using electricity, the demand of 122 gigawatt against the availability of 110 gigawatt. So a shortfall of 10% is converted to a load shedding. So immediately after load shedding, what happens? Normally, after load shedding, people will turn off their all the devices and sit quiet, turning on a single light and wait for your power to come. Correct. So automatically, after 15 minutes, many people it is a normal sentiment that people will turn off all their load and they'll wait. And after that, once you make it on again, you'll have a lesser load. Okay. So now for this, we need to focus on two aspects. One is energy management and use of renewables. We'll see what is energy management now. So you can see that energy management is nothing but it is a judicious and effective way of utilizing your energy. So judicious and effective. So at the same time, one is your you should give a good judgment or good price to what we are doing, as well as you have to also look at the management part. That is, you have to keep the efficiency at higher level. So how we can do this energy management? Before that, we'll start with what is the need of energy management. So you have to focus on thing like what is the current energy scenario that we have seen, and we have seen that the rise of energy is growing at the same time fuel prices are going. If this happens, this is a product. Energy demand and fuel price is a product, and if both of them go up, what is going to happen? It is going to cost your nation as well as yourself very high price. And what is going down is fuel resources. We are having, as I said, coal will last only for 100 years, next 100 years, and your oil will last for till 2045. Correct. So after that, what we are going to do? We will not have any fuel resources. Even the reliability of these power companies will go down. Why? Because if there's gap between your availability and your supply is widened, what will happen? There will be more and more deficit, and because of that there will be load shedding. So that gives rise to energy management. So how to do this energy management? So there are three major things what you can do by which you can do energy management. First thing is you have to set up distributed generation. What do you mean by distributed generation? That instead of setting a big plant, which is away at 100 kilometers, 200 kilometers, and taking energy from that to your house, you have to set up small hydropower plant, small what you can say thermal power plants, and small cogeneration plants. What is cogeneration? Cogeneration is generating electricity as well as generating heat at the same time. So if you go to a sugarcane industry where there is need of electricity as well as there is need of heat for your boiler, what you do, you will set up a cogeneration plant there. What this cogeneration plant will do, you know that sugarcane after extraction will give you a byproduct which can be used to burn and produce heat. And the same heat can be used to produce electricity. So the byproduct of sugarcane is now can be utilized to generate heat as well as electricity. So this is called as cogeneration. So there is generation of electricity as well as generation of heat. So by using one fuel, you can generate two things at the same time. Similarly, you have to do a peak load management. We'll come to that later, peak load management. We'll see that in detail. And finally, you need to do energy audit. So combined heat and power, as I said, combined heat and power, or it is also called waste heat recovery system. That means whatever waste you have in a chemical process industry, cement industry, steel plant, that you can use to that you can use to generate power. Power means in terms of electricity, and generate heat. At the same time, you can also generate steam. So this all this is many times called as tri-generation or quad generation. So these plants are becoming famous. You can set up these plants in your premises or in your industry, like chemical process industry, cement industry, and steel plant industry. There are many industries. That I gave you example of sugarcane industry recently. So all this can be utilized. Then you have peak load management. I'll tell you with the help of graph what is peak load management. So this is also in local this thing we call it as load scheduling, correct? Load curtailing. So what is load and what is load curve? Anybody? Anybody from audience knows what is load and what is load curve? You can type in chat. You know what do you mean by load and load curve? So if you draw uh, if you draw a graph of use of electricity with respect to time, it is called as load curve. And what is load? So anything which is connected to your power supply is called as load. So what happens in the morning at your home? What do you do? So whenever you get up, you immediately turn off your AC, correct? Then you turn on your lights, fan, and other equipments, and you go outside your house, correct? After you finish everything, breakfast and all, you will move out of your house. So immediately what happens when you move out of your house? That the sudden there is load which which was there earlier drastically reduces, and that leads to what? Sudden load change. So everybody in their house, they go to workplace, correct? So what happens in household or your home? Your sudden load will decrease. And what happens when you come back? When you come back, you will again turn on your AC, and again your load will increase. So this leads to your variation in load. We'll see that later. And what time of use uh, you turn on your AC or fan or tube or TV, anything, any load determines that at if say if you are turning on your AC at 6 in the evening, and you will turn it off at say 10 at the night. So this time of use, you have to find out what is the tariff inside it. So now these utilities like MSCDCL, Tata Power, Reliance are thinking of smart meters which will be fitted to everybody's house, and they will encourage to use electricity at the uh, at the low low load time, and at the high peak time what will happen? They will discourage you to use the electricity. How they will encourage? They will bring the tariffs at very low rate during the off peak time, and during the peak time they will increase the tariff to a high level. So you can see here that there is a peak here, and so I have not taken here time. So if you look at this, this is load, and this is your time. So a plot of load versus time is called as load curve. You can see that this is your evening time. So this is 4 to 5. You have turned on everything. 5 you went out. So you came back at 6:30 at your home, and till 10, 11 you were there, and again after 11, correct? This is night time where you have decreased the load, and morning time you turned off your AC and all, and you again went out, correct? And this load is increased because all people went to office again back, and they started consuming electricity at the office, and again it increased, again it got decreased, and this level again was back. So this is called as a daily load curve. So 1 day time, it is daily load curve. We also have monthly load curve, yearly load curve. Okay. So you can see that now what is the role of energy manager? The role of energy manager here is to decrease this, fill these valleys and cut these peaks. Why we need to cut this peak? We don't want this area. Why? Because as we have seen that we have installed capacity somewhere here, 110 gigawatt, and we are using 120 gigawatt. So 10 gigawatt rise will do what? Load shedding in some area of country, correct? So if you want to reduce this, what you can do? You have to slash these peaks and create and fill these valleys. So how you can do this? So nowadays, if you have heard a word called as smart grid, there is a concept in smart grid called as smart metering or automatic metering infrastructure. So that allows you to have TOD, that is time of the day tariff. So you will have equipments in your home where you will have a display, and that display will show you that tariffs are down. You can start your washing machine. Tariffs are down now. You can start your motors. Tariffs are down. You can start your other equipments. Got it? And when you have high tariffs, they will tell you that please don't turn on this geyser. Please don't turn on AC during the peak load time. So this will help the utility to flatten the load curve. So what is our main task? We have to flatten the load curve. Got it? One terminology in this is base load. Can you see this line? So what is your observation that this line is there for every minute or every second? You can see that this is the base load. That means even if people are not there at their home or they are away from their house or wherever they are, there is certain amount of load which is always there in picture. Okay, that is called as base load. So what we can do in this scenario is we can shift this base load on a hydropower plant or nuclear power plant, and we can have this variable load on a thermal power plant or renewable energy sources. So these renewable energy sources, they vary according to time, and they vary according to the wind or the radiation from sun. So you can utilize this much part whenever you require it. And base load is always on, so you can shift this load wherever you get a constant source of energy like nuclear energy and hydro energy. And last point in today's webinar is energy audit. So why we should go for energy audit? What is energy audit? Like you do audit for your financial year, like you have a CA, we have energy audit for all the industries. Why we should go for energy audit? See, you have equipment. Say, take your home and you have a fan fitted at your home. That fan is on for 12 hours a day, and it is consuming electricity of 100 units, okay, yearly. So if you have a issue with your fan, and if your fan gets winding gets burned, what you do? You will go and rewind that fan and again fit it. But now instead of consuming 120 watts, it will consume 240 watts. Now if you look at the yearly pattern or yearly summary of that fan, how much energy that fan consumes, is it not better to replace that fan? Because 120 units of energy is almost equal to new fan. So instead of using a old fan and retrofitting it and rewinding it, what we can do? We can change that equipment and we can have a new equipment which will consume less energy and ultimately will do a saving on electricity. So who tells us whether to use this fan or whether to discard it or to buy a new one or to do a maintenance? It's the energy auditor. So that is why it is nowadays it is compulsory every year for all the companies to do their energy audit. So what is this energy audit? You now know what is audit. So what are types of audit? We'll see. So types of audit are a walkthrough audit, then we have a preliminary energy audit, and we have detailed energy audit. So walkthrough audit means what? You have to just walk through any industry and find out by looking, monitoring, targeting. You have to find out what are the devices which are old, what are the devices which are inefficient, what are the devices which consume lot of current, power, and which are not running well. So this is a walkthrough audit. What is preliminary energy audit? Preliminary energy audit, you have to first conduct a meeting of all the managers and you have to talk with them what are the problems associated with your equipment. Are your equipments energy efficient? And you have to suggest some changes to it. And last is detailed energy audit. There are two types in it, electrical and mechanical. In mechanical, we have to do a thermal type of audit. So, boilers, compressors, pumps, all these are mechanical equipment. For them, we do a mechanical energy audit. Electrical energy audit is done for HVAC, motors, and uh, your lighting load. Lighting load means whatever lights you have installed in your industry. So we'll just see the methodology. So first is site or plant visit. Then you have general inspection and observation. So you have to do some on-site measurements for doing the energy audit. So you have to take equipments, a lot of equipment and do a power measurement. Power measurement has got voltage measurement and current measurement. Then we have total harmonic distortion measurement. And second is flow measurement. So you need to carry a flow meter which is connected in series with your fluid or your air. There are two types of meter. One is air flow meter, other is your fluid meter. Then you have temperature. So in big industry, it is very difficult to measure temperature. So what you do, you need to have a equipment called as infrared thermometers, and you have to go and you have to just point that thermometer on a boiler. So by keeping a safe distance, you can measure temperature. Then you have barometers and you can measure pressure, and there are a lot of such equipments you require for this on-site measurements. So once you do the measurement, you have to analyze the measured data. So it is said that whatever you can measure, you can target. So if you cannot measure anything, you cannot say that you can change this, correct? So first thing is you should measure. So in order to measure it, you should first find out your consumption profile. So you have to find out what is the hourly data, what is the daily data, what is weekly data, what is monthly data, and what is yearly data. So all this data, by this you can come to a conclusion that can find out the profile of your consumption. So looking at the profile, say if there is a lighting load and you are looking at the profile and you can see that during hourly chart there is lot of uh, lighting load which is coming into picture in daytime. So this is one observation you can make and tell the authorities that you have to turn off the light during your daytime, or you have to have a LDR or any automatic device which will cut off the light whenever it is not needed. So, and last point is finding the ECO. ECO means what? Where you can conserve your energy. You have to find out the areas where you can conserve your energy. So, let us see an example. If you have a pumping system, so you can see that there is head versus discharge curve. Look at this. That if head is less and discharge is more, and your head is more and discharge is less. You have to find the best efficient point in the system. So this is what your pump characteristic. Once you get this characteristic, you have to find this efficient point and you have to operate in the same region. So this was just an example. You can find many examples like this. So what are the conservation energy conservation objectives in pumping system? So first is throttling, then impeller changing, then impeller trimming, changing pump set, and uh, installation of a variable speed drive. So you can see that by changing all these things, this will cost you very less. Changing pump set or impeller trimming if you do, or throttling if you do, this will cost you very less, but it will play a very big role in the billing of these pumps. So when you'll get a bill of this, you'll get a lesser bill, which will save your money. Economics is a main part of this, and economic plays a very important role. So how should be our system approach? So once you have a pump modification result, you have to again check whether that pump is operating at a good motor loading. You have to calculate motor efficiency. If you have motor loading, you have to check how that motor needs to be improved. So either you can change the motor or you can change it from delta to star. So once you change from delta to star, what will happen? The power consumption will reduce by 1/3. And the last part of this webinar, which is renewables, as you know that this has become nowadays very common topic. So what are the renewable energy alternatives? First renewable energy alternative is solar. So solar you can use direct or indirect methods. And other sources are many. You know that wind we have um, what you can say geothermal. Then we have many other sources like this which you can utilize. There is also a concept of microgrid which is coming these days, where you can fit your solar and wind and connect that grid, small grid, to your main grid. Okay, so you can see solar as an option. So you can see that the sun is a constant source of energy and it never stops emitting radiation. So what you can do is you can take the benefit of this and you can use this large inexhaustible renewable source of energy. The power which is coming from sun is it intercepts the earth. And what is the power? 1.8 into 10 raised to 11 megawatt. So if you just see that if you can convert at least 1% of power, only 1% of this, you will be able to meet the demand of whole Earth. Okay. So what are the advantages? This is environmentally clean and it is free of cost. What are the disadvantages? So it is very less utilized, or we can say that the conversion of the radiation to actual electricity is very less. And other problem is there are some countries in north side of earth, or south pole or north pole, where there is no continuous availability of solar as an option. So we will now see what are the methods of solar energy utilization. One is direct method. So we can use solar thermal, solar photovoltaic, and indirect method we can use hydroelectric power, wind energy, and biomass. Okay. So you can see that most of these energies that they are experimentally used. They are not used in a wide range. So you can see wave energy, ocean thermal energy, and tidal marine currents is nothing but tidal energy. These are indirect methods of your renewable energy which are not used. Okay, so what are the comments on this? When used directly, one needs large collecting areas for the storage, and the initial cost is very high. The second comment is the solar option can be can make a very big impact on India's energy needs. So this is some data. I think this is related with your uh, sold data. For now, you can consider. So now these figures have grown to very high level. Now existing wind capacity nowadays is around 27,000 megawatt, and the solar has increased to 2 to 4 gigawatt installed capacity. So now projects are not completed yet, commissioned yet, but you'll see in 1 or 2 years, you'll see 1 to 2 gigawatts of energy. Hydrogen as an energy. So this is still a question mark, and hydrogen is available in abundance, but we are not able to convert that hydrogen to storage. So storage is the biggest problem. So these are properties of hydrogen. So it is colorless, odorless, tasteless gas, and it is 14 times lighter than air. So if you see hydrogen, it will go directly to a ground level because of, and it travels at a very high speed. So you cannot see hydrogen molecule in air for less than 1 second. So within 1 second, it will travel 130 meters. So I think I will skip this part. How we can to produce electricity. Now, recently Tata Power has taken a patent from IIT Bombay, and they are going to install hydro H2O electrolysis inside cars. So this is the future. So this is one of the energy which will come in future. So after you can say 2050. This is how we can store your hydrogen in fuel cells, and cars will have hydrogen as resource. Okay, so I think I've covered many points in this, and summary of today's webinar: energy and economy have very close correlation. Then we have energy management. So every bit of available energy needs to be utilized properly, and renewable energy needs to be exploited. And finally, hydrogen, which is future of renewable energies, can lead to sustainable development. So thank you. Thank you.
Thank you very much, sir, for giving this valuable informative session. Your thoughts have truly inspired us. Our program was a huge success. All thanks to your enlightening words that inspires our students and faculty members. Now, I would like to request Dr. Mullah to take a charge and do a vote of thanks. Thank you.
Thank you, madam. Actually, principal sir had to take this presentation, but unfortunately, due to some important work, he could not attend the webinar and he could not deliver the lecture. At 11th hour, we requested to Professor Marathi sir to deliver the lecture, and we uh, sincerely convey the thanks to Professor Marathi sir. He accepted our invitation, and at 11th hour, he could deliver the lecture on role of energy management and energy crisis. So I really thanks to Professor Marathi sir. Also, I thanks management, principal, all supporting staff member for making this event successful. And last but not least, I sincerely thanks to all students for participating in this program. Professor Marathi sir has given very valuable knowledge or information about the role of energy and energy management. He explained what is the importance of energy, what is the per capita energy consumption, and how much is the consumption of oil in India. Also, he explains about the factors to be considered for maintaining of maintaining the balance between environment and energy consumption. He also explained various types of energy. He explained what is the energy management, what is the energy audit, and also he could explain what are the future options of the energy. So thank you very much. And with this vote of thanks, I declare that this webinar is concluded. Thank you, sir.